Here we are in our new unit, folks. This is called Systems of Equations. We'll be solving systems a couple of different ways. Our first method of solving is by graphing. So this is part one, and then we'll finish up in part two with more real-world examples. But for now, we're just going to get the basic skills down that we need. Well, before we get too far into it, what in the world is a system of equations? Well, simply put, a system is a group of equations that share a common set of variables, x's, y's, whatever, and it's important to seek those equations' common solution. So what we want to know, basically, is where the graphs intersect. All right, and remember, all points of intersection on a grid like this is going to be an ordered pair. So our first number, all right, will be the x-coordinate. Our second number, remember, is the y-coordinate. So our goal today is twofold. First, we're going to get some practice graphing our lines for various equations. And then finally, we're going to be able to identify those points of intersection. Where do our lines cross? Now, to help you guys out, I'm going to be working in two colors today, red and blue, just so that way you can see the difference. If you would like to work in two colors, you may. Again, it's easier to erase if you just work in pencil, but sometimes it's easier to see if you got two colors going on. So take a look. Here's how we write a system. A system is simply two sets of equations that are put together. And our goal is to figure out where they intersect. Now today, I know that seems kind of dumb, so what, who cares? In our next lesson, we'll talk about more real-world situations. Why in the world would we use this to figure various items out, various ideas? So for now, we're just practicing the skill of finding that point of intersection, labeling it, and then also graphing the lines and labeling those points of intersection that we find. So take a look. I've got two lines going on here. One of them is y equals 2x plus 5, and that's this red line. Notice it crosses the y-intercept, or y-axis there at 5. That's the y-intercept, and the slope is 2. Notice from any intersection here, we can count up to right 1, up to right 1, and we're back on the line. So this is our red equation. Our other equation, negative 3x subtract 5, all right, that one, obviously it's the other equation, mostly because there's none of them left, but we can also see it has a negative slope, in this case, down 3, right 1, down 3, right 1, and it also crosses at negative 5 here on the y-axis. Our goal today is to figure out where these two lines cross. Graphing makes finding those points of intersection easier because it should be painfully obvious. In this case, it's right there. So we would write the solution, that's what we call that point of intersection, our solution as an ordered pair. So in this case, it occurs at the point negative 2, comma 1. And there we are, we're done. It's as simple as that. So again, we'll be spending our time just reading those coordinates, writing them down, and we'll also spend some time graphing those out. For the first few here, I've graphed them for you, just so we can practice real quick, and then on the back side, we'll practice graphing. So let's try another one. Take a look. Our graph here, we've got two lines drawn in. We've got this negative slope here, so I know it's the second equation, negative 5 over 4. So notice from any point of intersection, we can go down 5 over 4, and we're back on the line. Our other equation, if I can find my pen, there we go. Our other equation has a positive slope, in this case 1/4 up 1 over 4 up 1 over 4, crossing at negative 2. And again, we're going to try and figure out, well, where did those two lines meet up? So there it is, right there. Again, easy enough to do. So our intersection is at the point 4, 0 there on the, or not 4, 0, good Lord, it actually goes one down. Mark that out. 4, 1. There we go. Yeah, we're one down there. So 4, 1, simple enough. And that's what we're doing today, just finding these points of intersection. Not a big deal. Let's take a look at this one. This one strikes me as kind of odd. Notice in this case, I don't see where either of these lines are crossing into the other. I also notice something else that's interesting about this set of equations. Notice for our top equation, we've got y equals 2/5 x plus 2. So that's this red version. The bottom equation is y equals 2/5 x subtract 3. And notice it's down here crossing at negative 3. What makes this situation interesting is that the y-intercepts are different. Notice one crosses at 2, one crosses at negative 3. The other item that makes this interesting is that the slopes are equal. So here's the deal. If the slopes end up being the same and the y-intercepts are different, our lines are parallel. And if our lines are parallel, then that means they will never intersect each other. This is like a set of railroad tracks. They'll simply go on forever and never cross. Since they don't cross, that means there is no solution. There is no intersection point where our two lines will meet up. So for a solution, instead of writing out an ordered pair, we'll simply state that this situation has no solution. All right, so let's review real quick. Different solution types. The first one is one solution scenario. Our lines will intersect once and once only, and that intersection point is the solution. The other possibility that we just saw is what we call a no solution scenario. Our lines don't intersect, they are parallel. They are parallel. There we are. In other words, same slope, different y-intercepts, and we just saw that. Same slopes, different y-intercepts. Well, maybe if it'll focus. There we are. Same slopes, different y-intercepts. There is a third option, sometimes referred to as infinitely many solutions. Other books refer to it as an identity situation. Let me show you. Here's our next system. Notice it's not graphed for us, so we're going to go ahead and graph it together. The top equation's all ready to graph. It's in slope-intercept form, so I'm going to go ahead and do that real quick. Let's make it red. That way we know what it is. So I'm going to start at -5, so all the way down here. We'll make a mark. And then our slope is 4/5. So I'm going to go up 4, 1, 2, 3, 4, and then to the right 5. 1, 2, 3, 4, 5. All right. We'll grab a straight edge. We'll draw it in here real quick. And notice it's in the lower part of the grid here, so it's not going to need too long of a straight edge to make it work. There we go. Line like that. And again, we definitely need to use straight edges. All right. These lines have to be nearly perfect in order for our graphing to work out. If our lines are sloppy, then our point of intersection might be off. All right. Let's work out the other one. Notice this other one is not set up to be graphed, right? It's in a different format. You'll deal with this format more next year. It's referred to as standard form. Right now, we're not going to use it. We're going to change it out. So the first thing I'm going to do is subtract 4x from both sides. Notice that's a positive 4. And so to get rid of it, we'll subtract 4. 4 subtract 4 zeros out. That leaves -5y. So I'm going to write it over here. -5y equals, I can't take 4x from 25. They're not like terms. So we'll just rewrite it. -4x add 25. Cool. So we're off to a good start. We need the y by itself. Notice the 5 and the y are multiplying together, so we'll divide, -5 in this case. So we'll divide everything by that -5. All right. 5 divided by 5 is 1, so 1y. Negative over negative is positive, and we'll keep it as a fraction. 4/5 x. And then 25 divided by -5 is -5. Right? I hope that you see something here that kind of strikes you as odd. This was our original top equation. All right. Our bottom equation we just finished rewriting. Do you notice anything about the two equations? Okay, they're identical. So if I were to take a blue pen this time and try to graph this, we'd start again at -5. We'd count up 4/5, grab our straight edge, and try to graph it. Notice our two lines end up in the exact same placement. In other words, they are the same line. So how will we know if we have one of these situations where every single point touches, not just one, but all of them? Well, we know that because we're dealing with the same line. All right, and that's how they'll try to fool you, say on a test, a quiz, that kind of thing. We'll try to fool you by rewriting the equations in such a way that they won't look the same. But as soon as you put them in the same format, they'll look identical. It'll be very easy to spot. So in this case, I would say that I have infinitely many solutions. In other words, any point along these lines could be considered the point of intersection. So we've got an infinite number of them. Right. Let's try another one. Right. This one here we've got set up ready to go. I've already got my pen out, so let's get started. Our top equation is ready to graph, so I'm going to make it my blue version. In this case, we start at 4, so all the way up here. Our slope is 1/2, so we'll go up 1, right 2, up 1, right 2, up 1, right 2. Remember, to go in the other direction, we'll just reverse that. So down 1, left 2, down 1, left 2. You get the idea. Let's grab our straight edge here. We'll try to draw this in. Oh, goodness, it just barely fits. There we go. And we'll put arrows at each end. There we go. All right, well, let's rewrite that next one. Again, we want it in the correct format, in this case, slope-intercept form for our graphing purposes. So it looks like I've got a -x there, so I'm going to add an x to both sides. So 2y stays, we'll write it over here. 2y equals x plus 4 doesn't work, so I'm just going to write it in as x add 4. We can't actually do the addition, so we'll just write it down. All right, we need to divide everything by 2 to get y by itself, so let's divide everything by 2. 2 divided by 2 is 1. Remember, there is a 1 with the x there. 1 over 2 is just 1 over 2 times x. And then 4 divided by 2, well, that's just 2. There's our next equation. So let's write it down. I need to start at 2, so that's here. Our slope, 1 over 2, so up 1, right 2, up 1, right 2, up 1, right 2. Again, the other direction, down 1, left 2, down 1, left 2, down 1, left 2. That seems strangely familiar. Well, let's graph it. So we'll line up our sticky note here. Again, grab a straight edge, piece of paper, something. There we go. Well, I'm noticing something odd again. Notice how our lines are parallel. They don't seem to want to touch, and I can confirm that. Our slopes are the same, but the y-intercepts are different. So remember, if the slopes are the same, but we've got different y-intercepts, then that means there is no solution. In other words, these lines do not cross. They're parallel. So for a solution, we can just simply say no solution. All right, easy enough. Let's try 2 more real quick. All right, these are already in the format we want. They're both in slope-intercept form, so let's go ahead and graph them. This top one will be my red version. So positive 2 is where we start, so we'll start there. Our slope is negative 3, so we're going to go down 1, 2, 3, and right 1. Down 1, 2, 3, right 1. Down 1, 2, 3, right 1. To go the opposite direction, we do the opposite. Up 3 this time and left 1. And we don't have any more to go, so we'll have to stop there. All right, let's draw it in. Again, be careful. We want these to be as exact and nearly perfect as we possibly can. All right, we do not want to be sloppy on this. Neatness counts in this case. Neatness does count. All right, so there's our red version. Simple enough. Let's grab the other one. In this case, we're going to start at negative 4, so that's all the way down here. Our slope is 3, so up 3, right 1, up 3, right 1, up 3, right 1. And then, of course, we could go down 3 and left 1. That works as well. Notice that intersection point came up pretty quick for us. By graphing it, we can see very clearly that our lines are going to hit right here at the point 1, negative 1. So that's what we'll write as our solution. 1, negative 1. Okay, so one solution scenario, infinitely many solution scenario, and then, of course, a no solution scenario. So that way you can see all of them. Let's try one more. Take a look. I know this is going to have one solution for one simple reason. The slopes are different. Okay, if your slopes are different, you know you're going to have one solution. So that makes that easy. Let's start with the top. The top one here, we're going to start at negative 3. So negative 3 all the way down here. My slope is negative 2 over 7. So we're going to go down 2 and over 1, 2, 3, 4, 5, 6, 7. To go the opposite direction, we'll go up 2 and then left 7. So there's our line. Only 3 points this time, and that's okay. Not the end of the world. I think I can line this up fairly well, even with as short a piece of paper as I got. Yes, indeed, look at that. Minor miracle. Mr. Lamar can draw a straight line. There we go. All right, well, let's try red this time. That way we can see the difference in the equations. And again, you don't have to use 2 different colors, but I do find it helpful just to see the difference. So negative 3 again. Well, that was easy. There's our point of intersection. Let's go ahead and graph this other one. Slope is 4. So we'll go up 1, 2, 3, 4, right 1. Up 1, 2, 3, 4, right 1. And then, of course, the opposite direction, down 1, 2, 3, 4, and over 1. Ooh, just about didn't make it there. We can draw on the line because we were asked to in our directions. Go ahead and draw those lines. Find that point of intersection. Well, in this case, it's not that difficult. In this case, notice that their y-intercepts were both the same. They're both at negative 3. So the equations themselves actually gave it away. We didn't necessarily have to graph it. We can see right there that they're going to cross at that spot. Sure enough, they do. So our solution in this case is at 0, negative 3. So again, our purpose today, twofold. One, to give us some more practice here on our graphing. Some of us are very good at that. Some of us, we need a little more work, and that's okay. The other is to make sure that we can spot these points of intersection. In our next lesson, what we're going to do is we're going to take these equations, apply them to real-world situations, and talk about what does that point of intersection mean, and what can it tell us about our problem where we've got maybe 2 different scenarios playing out, and what does that intersection mean? Or what does it mean before we get to that point of intersection? What does it mean after that point of intersection? intersection. So again, make sure you write any questions that you have for me down, bring them with you to class, and we'll talk about it. Have a good day, folks.